Alrighty. Hello, everybody, and welcome to today's look at the third phase of prompt engineering, or the 12th lecture in this artificial intelligence course. Today, we're going to look at constraints as it relates to prompt engineering. Let's get started. Okay, so let's start with the beginning question. What are constraints in prompt engineering? So, constraints are the guardrails. So, you install those in a prompt, or you write those into a prompt to shape how the AI responds, not just what it responds to, but giving it some limits. So, sometimes I say constraints are the flip side of context, which we looked at the last section. They're the rules or the parameters that add specifics to prompt, or to narrow, or to widen the response output. So, example, it's the difference between asking a contractor to just build something versus handing them a specific blueprint with specifications. The output gets to be only as precise as the instructions that you provide it. At their core, constraints operate on two axes. Scope being the first, how broadly or narrowly the AI interprets the topic. A prompt that you could write like explain climate change invites a response that covers science and politics and economics and history. But adding to the prompt, focus only on the impact on Arctic ecosystems will collapse that scope down, and it brings the universe into one manageable territory rather than opening up that scope to a broader field. So scope narrows it in that way. The second axis is format, the structural shape of the output. This can include things like the length or the style or the persona or the tone or the syntax, even the physical arrangement of information on the page. So a simple constraint you could add to a prompt is in 100 words or in a bulleted list, to present a format that it can constrain the outputs to. There are various types of constraints. The first one we're going to look at is a length constraint. So this is a simple one. It's very effective, but things like keep it under 100 words, or write exactly 5 sentences, or respond in no more than 3 bullet points will limit and constrain that output. It forces the AI to prioritize. Like a 50-word limit explaining photosynthesis will decide what's essential and what's expendable. Often it is the editing work that we would normally do is done by adding a constraint in the prompt engineering. The second thing we'll look at is audience constraints, where we calibrate the complexity of the output and the vocabulary by specifying who the response is targeting or who it's for. For example, explain this to a grade 5 student. Write an audience for medical professionals. Assume the reader has never heard of machine learning. This controls many of the micro decisions that the AI makes all at once. Things like vocabulary and sentence lengths, and the use of or lack of analogies, the assumed prior knowledge, and the level of abstraction that it's going to use. We can also have a persona constraint. This is where we assign a role or a voice to the AI. So you can see how this is very similar to what we looked at in the context aspect in the previous phase. So example, adopt the tone of a skeptical journalist. Respond as a Socratic tutor who answers questions with another question, or write as a Victorian era naturalist. A historian and an economist will describe the same event through entirely different lenses, and therefore put a constraint on how the output is shaped. The fourth one we're going to look at is structural format constraints. These dictate the physical architecture of the response. Like we said before, like length, but we use something like a 2-column markdown table, or respond using only numbered steps, or write in the form of a newspaper headline followed by 3 supporting paragraphs, or begin with a thesis statement, provide 2 counterarguments, and then rebut them. Useful when used in a workflow or a presentation or a document where consistency matters. The fifth thing we're going to look at is exclusion constraints. This is where we're telling the AI what specifically not to cover or what to leave out. For example, do not include the method body, only the function header. Avoid discussing economic causes and focus only on political ones. Or do not use jargon or technical terminology. The sixth one we're going to look at is the linguistic or the syntactic constraints. They govern the mechanics of the language itself. So, for example, find the final sentence must be a rhetorical question, or use active voice throughout, or write entirely in the present tense, or every paragraph must begin with a topic sentence. The seventh thing we can look at is positional constraints, where we specify where certain content must appear in the response, like begin with the most important point, end with a call to action, or state your conclusion first, then provide the supporting evidence. So now the structure and the position of the output is constrained or specified. All right, so let's move on constraints, and we're going to move to a little more of an advanced technique called chain of thought engineering. So this is a next level type of constraints. So we're going to look at this thing that comes from sort of an engineering background, the chain of thought prompt engineering. It's a technique where we ask the AI to essentially show us the work, show us how it actually thought through this process, give us the internal steps of reasoning. So to do this, when you create your prompt or draft up your prompt, you add phrases in the prompt as simple as show the steps in your reasoning, or explain with step-by-step instructions, or justify your steps in your answer. But let's look at a few more examples. Specific examples. Calculate the force required, justify your choice of formula, and show all substitution steps. Explain the major causes of the Cold War. List each cause and show the logical link to the resulting tension. Solve for x in the equation 3 bracket x plus 2 equals 15. Explain with step-by-step instructions as if teaching a peer. Balance the following chemical equation. Show the steps for adjusting the coefficients. And trace the output of this recursive function. Show the steps for each function call. Constraints pair very powerfully with chain of thought engineering because they can be applied not just to the final answer, but to the reasoning process itself. So let's look at an example without a constraint. Solve for x, 3x plus 2 equals 15. Or solve for x, 3x plus 2 equals 15. Show each algebraic step. Label each step with the property you applied. For example, distributive property, division property of equality, and write for a student seeing this equation type for the first time. So here you can see a lot of prompt engineering techniques, including the chain of thought engineering technique, with a constraint to really provide a much more structured output. Here we see that the constraints govern the granularity of the reasoning shown. We see every step. The meta commentary required, where it's labeling each property, and the audience that it's a first-time student. All right, let's move forward again. Now we're going to look at constraints and tree of thought engineering. So this isn't the same thing as chain of thoughts. Let's take a look at tree of thoughts. So tree of thought or tree of thoughts is another advanced constraints technique that uses a branching technique. So it's called tree because if you think of the visual of a tree, but flip it upside down, it starts at the base or the roots and then it branches out like a tree. So we're going to ask AI to explore multiple paths of reasoning, and at each step, explore the promising ones and disregard the weaker ones. Let's look at some examples. Draft a story opening. Generate 3 hooks, evaluate which is the strongest, and then write the opening. Optimize this loop. Propose 2 alternative algorithms. Justify the faster one and provide the final code. Set a new marketing budget. Define 3 cost-cutting options. Assess risk for each and select the safest one. Analyze this circuit. Postulate 3 possible failure points. Rank them by likelihood and identify the most probable one. In tree of thought prompting, constraints do double duty. They govern each branch, and the selection criteria is governed between branches. We constrain the branches. Generate 3 possible hooks for this essay. Each hook must be a single sentence and use different rhetorical devices. That's constraining the branches. But we're also constraining the selection. Evaluate each hook. Select the one best suited for a grade 12 academic audience. Justify your choice in 2 sentences. So This is the tree of thought engineering technique. Without selection constraints, tree of thought can devolve into AI just picking arbitrarily or defaulting to the longest or most complex option. Sometimes we see this quite a bit in AI responses. It's very long, very detailed, and not at all really what we're looking for. So the constraint gives the evaluation step and an actual criterion, which is what makes the branching exercise meaningful rather than just decorative. All right, so we're going to wrap up today in this phase of prompt engineering using constraints, and let's summarize what constraint prompting can do. So one thing we can do is those two advanced techniques can be synergized together. We can take chain of thought and tree of thoughts and put them together. So here's what we would do. One, we would prompt to generate multiple thought paths, tree of thoughts. Two, we would prompt to elaborate on each path. That's a chain of thoughts within the tree of thoughts and explain the step-by-step reasoning. Three, we would prompt to evaluate and select, that's tree of thoughts, by assessing these detailed paths against the given criteria. Four, we would prompt to justify the selection. So that's a chain of thoughts within for that tree of thoughts, why a particular path was chosen over the others. Five, we would prompt to detail the final steps, the chain of thoughts for their final answer, and present the solution with its final sequence of steps. Let's see how that might actually look. Write a persuasive essay. That's our task. Generate 3 strategies, tree of thoughts. For each, outline the rhetorical steps, select the strongest, and explain why. That's our chain of thoughts. Prove the triangle congruence theorem. That's our task. Propose 2 proof methods. That's branching off into tree of thoughts. For each, show the step-by-step derivation. That's chain of thought. Select the simpler proof and explain your choice. Again, this is the result of the tree of thoughts. And finally, refactor this code. That's our task, and we provided an example when we present the code to the AI. Propose 2 logic approaches. So we're branching off into tree of thoughts. For each, detail the steps and justify why one is faster. And that is our chain of thought, basically asking it to show its work. Let's look at some common mistakes that can be made in constraints as a prompt engineering technique. The first and most obvious is over-constraining. If we provide way too many guardrails, we're going to get robotic and stilted and much too simple output. If you specify length and format and persona and tone and inclusion and exclusion, you're going to refine your AI output. It'll satisfy the rules you provide it, but it's not really going to perhaps give you a useful output. As I stated here, it might produce something that was assembled by a committee. Another common mistake is vague constraints. They're worse than no constraints. Keep it professional. What does that really mean? It can mean different things for a legal brief versus a LinkedIn post. Precision in the constraint provides precision in the output. So don't make it too vague if you're going to add a constraint. And then we can have contradictory constraints. This is where the AI gets a little bit paralyzed, right? So for example, if we're asking for a detailed, comprehensive overview in 50 words, it creates an impossible target. 50 words for a detailed, comprehensive overview? How do I do that, right? If the constraints conflict, the AI will resolve this tension in unpredictable ways, not the way maybe you intended it to do it. So be careful of contradictory constraints. And finally, what about front loading versus back loading? Well, the order matters a little bit. Constraints placed at the end of a long prompt sometimes receive less importance or less weight than those we stated earlier. For critical constraints, consider placing them prominently near the beginning of your prompt or repeating them again at the end to make sure that they are covered with the importance or the weight that they deserve. The deeper skill in constraint design is knowing what types of constraints exist. It's developing the judgment to know which constraints to apply for which given purpose, how to stack before it becomes diminishing in its return, and how to specifically phrase them so the AI's interpretation matches your intent. And here you can see this infographic that is slowly getting built and has now added constraints along with task and content to our prompt engineering techniques. Thanks, everybody. I hope you have yourselves a great day, and I will see you again very soon.